para, and then I have my draft of the third one. So,
Okay, perfect.
okay. So, okay, so second para. Currently, several technologies are used to quantify skin rashes by segmenting and analyzing affected areas. Clinicians often rely on visual assessments, questionnaires, dermoscopy, and photo storage methods to track the progression of conditions like dermatomyositis. Visual assessments focus on changes in the rash's size, color, and spread, while questionnaires gather patient-reported symptoms. Dermoscopy and medical photography capture detailed images which are stored and compared over time to monitor changes. Additionally, advanced methods like K-mean segmentation break down these images into segments based on color and texture, allowing for more precise and objective measurements in tracking disease progression. However, most assessments still rely on clinicians' personal judgment and patient-reported data, both of which can be subjective and may not be ideal for detecting subtle changes in disease progression or for large-scale studies. And then my third paragraph. Despite the advancements in current methods for quantifying skin rashes, challenges remain. Many of these techniques still depend heavily on subjective clinician judgment and patient-reported data, which can be inconsistent and less reliable for detecting subtle changes. Additionally, the need for large and diverse data sets makes it difficult to apply automated tools broadly. To overcome these issues, we propose a semi-automated method using K-means clustering in the lab color space for detecting and measuring erythema in dermatomyositis. This approach aims to provide a consistent and objective measure of rash severity, improving the accuracy of disease progression and tracking. Our goal is to create a detailed patient-labeled and physician-verified data set that will enhance both clinical and research efforts, leading to better understanding and management of DM and the improvement of patient outcomes. That's it.
I am sorry when you were telling, can you repeat the last para?
The last part. Okay. Despite the advancements in current methods for quantifying skin rashes, challenges remain. Many of these techniques still depend heavily on subjective clinician judgment and patient-reported data, which can be inconsistent and less reliable for detecting subtle changes. Additionally, the need for large and diverse data sets makes it difficult to apply automated tools broadly. To overcome these issues, we propose a semi-automated method using K-means clustering in the lab color space for detecting and measuring erythema in dermatomyositis. This approach aims to provide a consistent and objective measure of rash severity, improving the accuracy of disease progression tracking. Our goal is to create a detailed patient-labeled and physician-verified data set that will enhance both clinical and research efforts, leading to better understanding and management of DM and the improvement of patient outcomes.
Okay, got it. So before I tell you like what my suggestions are, if you can go up, Vaidehi, what are your thoughts on this?
I think it's actually well written, don't you think so?
We will break it down. Hasini knows this. But yeah.
Okay, let me read it once again quickly, because at least the third paragraph when she read it, like I really thought it was like very well written.
Thank you.
So yeah, I'll give you some time to read. And part of today, I think 3 hours with my software engineer about this project.
Wait, you glitched. What did you say?
Am I audible?
Yeah, when you were talking, you glitched a bit.
Oh, okay. So today, part of my day, a good chunk of my day went to discussing software engineer friend.
Oh, he froze.
Is it only me who can't hear Kaushik very well, or
he froze for me?
Okay, yeah. I was wondering if like my internet is lagging in some sense, but I don't think I can hear him.
Yeah, I know. Sometimes oh, now I can't even see him.
Yeah, same.
Usually, I think he has to rejoin because usually, and he has to rejoin for it to start working again.
Oh,
But that's okay. It's a Zoom meeting. It happens. It is.
this is actually nicely written. I mean, since I'm also new to this, I cannot find any flaws with your writing. I'm
Thank
sure
you.
like he's gonna break it down and teach us both meanwhile, but yeah.
Yeah. I think I recently started we started recently going into like me actually writing because before it was kind of just like um him explaining
PPTs. Yeah.
and it's like I was learning what everything like the aspects of research and then I would
Mm-hmm.
do a presentation over what we learned.
All right.
Yeah, this is like for the past like few weeks I've been writing. Like this is my second draft of the second para. This is what it was before. And then these are the notes over what I needed to fix. So I did all
Are,
of that and I rewrote
oh,
it.
are you like moving things? I think the screen
Oh
froze
yeah,
for
wait, I
me.
paused. Yeah, I paused the screen so that I can open my notes.
Oh,
Yeah, these are my notes that I took over all the stuff that I had to change.
right.
And then this was my first draft. I think he said like this one was what it was. I talked more about identifying the changes rather than quantifying the changes.
Mm-hmm.
I had to talk more about what the actual
What the actual
what the actual tools were and not their limitations.
limitations.
So in this one, I just talk about like I described what the current tools are, and this one is all just the limitations and then what our goal is in the study.
Right.
Yeah.
Yeah, there's some
Oh, you're
issue
back.
with this. Yes, I will. No, I am going to join through my phone on
Okay.
my own internet. So that we can make sure consistent.
Okay.
I don't.
Mm.
Okay, we'll come back. So part of my day, I spend a good chunk of my day with discussing with my friend regarding the direction that we have to take with, this paper and analysis and what is available, right? So uh, before I go, Vaidehi, what did you feel about the writing part and the content?
Wait, who you
I
asked?
Yeah, I mean, I really feel like it's well written. Like maybe once you say
Once you say
what you feel is,
what
I don't know, missing or where the focus should be, I'll be able to see it more. But for me, it feels like I don't know, maybe there might be like something in the second paragraph, but I felt like the third one was like it explained things in a good flow. I actually don't know. I think you have to start for me to understand like what will you even pinpoint in this? I can't even understand like how will you break this down?
Okay. So, Hasini, what is the core of the second paragraph?
The second paragraph is to identify the current technologies and how they're used like currently. Or did he freeze again?
I think so.
I joined
Uh-oh.
on my phone, but
Oh,
I can, yeah, this will be better. And I will not freeze again. This place has spotty Wi-Fi. I'm in
okay.
part of the place, so I don't get disturbed. Anyways, coming back to what I wanted to talk about, what was the core of our second paragraph is supposed to be the current technology, right?
Mm-hmm.
Talking about what is available out there, not critiquing what's available, but more about stating what is available. And if you
Yeah.
can share your screen, are you doing that?
Yeah.
Oh.
Yeah, let me do it, like reshare it.
Mm-hmm. Yeah, now I can see. So
Okay.
if you can see in the second paragraph, currently several technologies, that is good, but you need to use less words like is, the, that, currently, or any adjectives to talk
Okay.
about your work or in a research paper. If you read those papers, you'll see very few cases of although. These are filler words,
Okay.
right? So this is a good chunk of important information. Now, what I'm going to inject over here and kind of what I wanted to see you do is think about current technology. Our paper is a technology oriented paper,
Mm-hmm.
right? Where we are focusing on talking about the method that is out there. If we break the problem down, our end goal is to take an image and be able to segment the rash from the image. That is the
Yeah.
end goal. How you get there requires certain frameworks to be built, right?
Mm-hmm.
Now, if someone wants to fund us, right, they will look at, do these people have technical capability of doing it? And if they don't have technical capability, they will do something. How useful is that information for someone else? Does it make sense?
Mm-hmm.
Now, Vaidehi can attest to this, if you look at the data set that was created for DART project, right? DART project is basically one of the postdocs, one of the rheumatologists, she went and collected images and labeled those images, along with highlighting the area of redness in the rash, right? This is very, very hard work, and not many people will have the resources to do it, nor they can do it in the first place,
Mm-hmm.
because dermatomyositis being a rare disease, you don't see those cases,
Yeah.
right? So first problem is dermatomyositis is a rare condition that we addressed in the first paragraph. Second
Mm-hmm.
paragraph, in first paragraph, we are mainly talking about characteristics of the disease and characteristics of the rash. If you look at dermatomyositis rash, there are going to be three stages, right? Anything, it is mild, moderate, and then severe,
Yeah.
right? And there are two approaches that we can take to segment the rash between mild, moderate, and severe. That is, either I'm using math, right? Or I'm using machine learning.
Mm-hmm.
Now you tell me, what are the fields that are easy to segment, easy to differentiate? Can I, using math versus using machine learning, is it easy for me to differentiate between mild and moderate using math, or mild and severe? And same thing for machine learning. What is easy?
I mean, to differentiate between mild and severe, because they're both
Mhm.
on like two different ends of the spectrum.
That is easy for which technique?
Oh,
Is it math or machine learning?
machine learning?
Machine learning, mild and severe.
Um, I don't know.
Mhm. It's okay, take a guess. No harm. Everyone is guessing at this point because there is no data.
Severe?
Severe with mild or
Like
moderate?
severe with mild, right?
Okay. See, that's again, we don't have answer. Everyone is guessing. What would you like to guess?
I would think currently I think it's math with mild and severe, but we're trying to incorporate machine learning into this, right? So
Mhm.
it's as long as, because I already saw that we had so many hurdles during the machine learning process, I'm
Mhm.
not quite sure if it's the most ideal or the easiest way right now.
Mhm.
So currently I feel like it's math. Maybe if
Okay.
we had such a high like tech team that was actually able to like create a very powerful machine learning source, then it would be machine learning. Because I feel why machine learning can be better if created right is because you can break red down into so many different pixels and so many different shades and colors, right?
Yeah.
So I think in that sense it might be a better spectrum to have. Between mild and severe, you might have like a bigger range if it was machine learning in terms of just shades of red compared to math,
Okay.
is what I
Okay.
feel.
Got it. So after a lot of debate for 3 hours, we had this debate. And then what we kind of concluded was, if you see, there are certain ways things work, right? Math works a certain way and machine learning works a certain way, right? So any machine learning algorithm, the code for original machine learning algorithm, which everyone is using now, was written in 1990s. And that was, one of the section of that paper was GPT. And GPT is the same. The code has not changed. The data that we are giving to the model versus what the model is capable of doing is continuously changing. Now, there is a limit to how much the model can output. ChatGPT will never be accurate. It will sound confident. If you see the second para and third para that she has written, it is
Yeah.
sounding like it is accurate, but it is not accurate.
Yeah.
It is predicting what is the next best word that can go there so that someone else will be convinced. But math is very accurate. There is no areas of gray and white, right? And so basically what I'm saying is, even if I had a data set of 1 million, right, images of well-labeled dermatomyositis rash, the model will never be more than 92% accurate or 95% accurate. That'll never happen. But
Right.
imagine, if I can do math, right, this math will always be accurate. So
Yeah.
math has a place and machine learning has a place. So if you think about the disease progression of dermatomyositis, right? You start off with a mild rash, it becomes more red, and then when it becomes severe, there will be scaling.
Okay. Yeah.
So scaling is what color?
It's white.
It's not red.
Yeah, it's white and gray.
Yes. So can your math account for difference between mild and severe if it becomes more gray? And if you're focusing on redness, it's not possible. It's going to fail in that. So what is the scope for our paper? Scope for our paper is going from mild to moderate. Can I differentiate between those? That is the scope for the paper. Then what is the next logical step is the machine learning model will be better at differentiating moderate to severe and mild to severe.
Right.
Does it make sense? So this is current technology that we need to current technology. And what I told next is the gap in the current technology. That should be explained very clearly. Okay. Then in current technology, right, when we say math, what type of math? Am I using algebra? Am I using linear or vectors? Blah, blah, blah. So that is the next question, right? What can this math not do? We should, that also comes in the limitation. Math can't account for whiteness, right? Because that is very variable, right? So in the first paragraph, we need to talk about dermatomyositis rash characteristics. Is it mild disease, moderate disease, severe disease? In mild, you have rash, moderate, you have rash, in severe, you have scaling. Those are the characteristics we need to talk about, and how the texture, like either the redness, the texture, or other features of disease activity. So the introduction is in the first para is mainly features of disease activity. In the second para, how are we tracking disease activity? Right? One is you are examining the rash. That is only one aspect. What is the other aspect of examining rash and disease activity? That is theta C score or the questionnaires. right? So we have physician who is going to evaluate the rash and come up with a CDASI score, right? And this score will segment the people into mild, moderate, severe, right? And then we can look at, longitudinally, meaning time day 0, day 30, day 60, how this is going to change, right? Now, when we have, when we were starting to build the data set, right, for the machine learning model, what was the first hurdle we came across? Nantakaran did not know what annotation tool she should use. Number one. Then number two was we did not know how to, you know, how to make the data set robust in the first place, right? What are the features that we are extracting? And
Yeah.
how do we say that is the gold standard, right? So those are the those are the consensus that someone has to reach and say that, okay, if you have to make a data set in the first place, these are the features that you have to extract in dermatomyositis. Now, in that features, if I say mild, should the feature extraction include rash, one color, and what are the features inside the rash? Do they deserve two different colors? If I have let's take example of severe rash, right? You have color one, layer one to highlight the whole area of the rash, layer two to highlight the scaling region. These can overlap, that is fine, but these are the levels of marking that we have to make, right? Where are the instructions for that? It's not there.
Yeah.
That is one paper. How do you create a data set, right? And once you create the data set, if you leave it publicly, right, even if my math code might be wrong, like Prakriti's code is better than my code, does it matter? Right? Let anyone use my data set and build a model. It is going to advance the field. So if you are NIH and I tell you, I am going to label the data set in this way because I am the expert and I know how the disease is going to perform over time, right? And I'm going to give you the scoring and I'm going to say that this is severe, mild, and moderate, right? On top of that, I'm going to have particular masks. I mean, basically robust labeling way, and I'm going to give you the way that I've labeled it. And the best glaucoma label data set, can you guess how many images it has?
1,000. I don't know.
Take your guess.
It should have more than that, but yeah, I don't know.
Yeah.
It
Hasini.
shouldn't have like millions.
I don't know. I'll say 1,500.
This number will blow your mind. 51. 51.
Oh, is it like the DermaNet where it only has like 49 pictures or something?
67. And DermaNet is not good. That is not a good paper, right? It's just a data set. Like someone has dumped the data set and told this is dermatomyositis. That's all. Deal with it, people. That's what they've done. Right? See, anyone can take pictures and say that, oh, this is dermatomyositis, right? Pictures. Who is the dermatologist who is going and labeling those images and marking the area of the rash? Who will do it?
No.
That 51 paper data set is the most used cited data set for glaucoma. Just 51 images. Two ophthalmologists sat together and told that this is what the disc sizes, the cup sizes, and then they published the paper telling how to use that data set. See, Nantakaran has developed a data set, right? We need to know how she collected, when she collected. Is it through Vectra picture, the 3D image, and what was the pixel density of that image? All these things should be defined in that paper. Just the data set is a paper. how she collected. That is the DART paper that Nantakaran is going to cite. And if we look at that DART project, they are looking at televisit versus clinic visit. That's the focus of the paper. But we should be able to make a paper separately for dataset, describing the dataset. That is a paper. Number one, dataset becomes a paper. Number two, math becomes a paper. Number three, the deep learning mechanism becomes a paper, right? Number four, if you cite all the work that you have done in these three regions, and then you give it to your grant, right? They will give you money and you will build a bigger data set. That is when the grant will say that the NIH will say that, okay, these people it looks like they can do the job. Does it make sense?
Yeah.
So when it comes to machine learning, right? This is what I was asking my friend. And then I had read up about it because I was, I don't know why, because I was dumb. So I just kept reading up about it. And then I realized that, so there is so think about it as a U shape. Okay. You have U shape. I'll try to flip the thing. Can you see white? Can you see my sheet? Okay, my face only is seen. Yeah, you can see this, right?
Yeah.
If you look at this page, this is x-axis and y-axis. You have x-axis and y-axis. And if you consider this to be 92% accuracy in any machine learning model, because of rules of physics or how it was written, you will never reach 100%. You will go close to 100%, but you'll never reach 100%. Now, no one can tell you what ChatGPT is doing, right? They can tell you that it is giving answers. That's all, based on the same code. This also is the same way. How it works is, let's say I have an image, rash, and I need to see if it is dermatomyositis or not. What is my output? Dermatomyositis, yes or no, right? If I flip a coin, will my answer be correct sometimes? 50% of the time.
Yeah.
So the model will start with 50% accuracy. That is flipping a coin. Okay. Next, if what the model does is, it will take the information, that is the picture of the rash, it will extract some features and it will pass it through different layers. Okay, this is one layer, this is one layer, this is one layer, this is one layer. And then at the end, the answer is yes or no. At the end, the answer is dermatomyositis, yes or no. Now, in these layers, it is extracting some information from the same picture, right? Now, in the first stage, it just guessed 50%, yes or no, right? Now, if I make some change over here, which I don't know, I call it I call it some change, right? Which I don't know how that change is working. I know I can increase the layer or decrease the layer. That's it. That's all I know. If I increase the layer, what is the probability? Now I'm changing how the model is giving the output. It can either become 48% accuracy or 55% accuracy. Which is better for us? 55%, right? Now I know I increased it. If it becomes 48%, do I want the model to go in that direction? No. So I will punish it if it goes to 48%, right? And then I want to make it go towards 55%. This model will make some other change over here. And then that will go towards 60%. So it keeps making changes to how these convoluted networks are working. And then eventually it will arrive at 82% or 90% accuracy. This is deep learning. And if it does a good job, right, it will move closer, 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 closer. And at some point, it will do a pretty good job. This is your deep learning models. And this is called UNet architecture.
Right.
And this is called convoluted neural network. See, you don't need to remember the terms. Has no significance in your life. If someone comes and tells, I'm using AI machine learning, and if they say 100% accuracy, now will you ever believe them? No. That's the takeaway. Does it make sense? So all this information with respect to UNet and when it comes to math, what kind of math people are using for rash segmentation in similar diseases like drug reaction, eczema, psoriasis, right? So these are the things that we need to talk about to some extent. But introduction, I would say, if we are talking about UNet model, there should be some research or something that you're quoting where someone has done something similar, right? See, just because people don't do stuff in dermatomyositis doesn't mean they're not doing implementing this technology in other diseases. So what should you do? You should look at the best and most robust data set, right? First, you start with data set. That is melanoma data set. Melanoma has 10,000 images which are labeled, saying that this is the boundary, this is, certain characteristics of melanoma, they have labeled it. And basically what happens in this melanoma label data set is you are having people would have used these models and gotten some weights. This after training at one endpoint it became 82% accurate, right? So that we call it as weights. So if I download these weights and use the model, I should be able to replicate the same level of accuracy without having to train the model myself.
So this
That's
model already exists, like
yeah,
out there. Like you can even download the 92% weight model.
yeah, yeah.
Mm-hmm.
For melanoma.
For melanoma.
Yes. So when you take a pre-trained model
Mm-hmm.
in melanoma, then you pass dermatomyositis into it, image into it. We need to see how it will, what output we will get. This is a shortcut way of going over here. Right? Now, let's say this was the same principle, right? We know one of the features of melanoma was encoded into one of the layers in neural network. If I take the black color of melanoma and say I replace it with red color over here in this layer, will the model be more tailored towards dermatomyositis? Yes. Right? So if I change, so what they do is they remove the layer which encodes for the color and then introduce new layer and then pass 30 or 100 images to train it. Now the model becomes better.
Right.
Leveraging pre-trained models. So this is the significance of mentioning about math, machine learning, what this machine learning is doing, what pre-trained models exist, and then the limitation. All the things that exist come in the second paragraph. All the limitations go in the third paragraph. Now you can easily jot down the limitations, right? Math has this limitation, this has that limitation, blah, blah, blah. Now, if you are writing about, see, third paragraph introduction is not supposed to be very big. What is our goal? Our goal is to publish math paper, right? So what are you going to highlight in the third paragraph? All limitations in the machine learning model.
Machine learning, yeah.
Does it make sense? And then your fourth paragraph will be, to address all these limitations, I want to focus on going from mild to moderate. And we are achieved that through the math. Does it make sense now? So in narrow context, in white people who have so and so, right? In white people who have dermatomyositis without calcification, if you are or scaling and you want to track disease progression, you should be using our math model, right? And then we will correlate with other stuff. And now the methodology becomes the hero after you have given the introduction. Are you happy with the introduction? Do you have any questions or any concerns? Did I convince you?
Yeah,
That
you did. But I just okay, so for the you are kind of like, isn't the paper about machine learning?
again, with what are we addressing in our paper? It's a case report where
Mm-hmm.
we are saying one case, right? What case did we take? The case that best suited our agenda. What was our agenda? Showing math works.
Hmm.
The case where math works. That is the case
Hmm.
I'm going to use.
Okay.
Now you know why people don't trust case reports. This is why.
Hmm.
And
Because
now,
now,
yeah, go ahead.
because we are like doing machine learning, like you are trying to train a model
Yes,
to see the images.
yes.
So
But where is data set,
yeah.
right? See, DermaNet is if my gold standard is DermaNet, which has 67 images,
Hmm.
including face, everything. Including everything is 67 images. We just hand, we have
Hmm.
close to 200 images. So
Right.
our image data set is more robust than
Yeah.
the permanent data set that is out there.
Right.
Imagine if we are not sitting on that data set. How
Hmm.
would you ever train your machine learning model,
Hmm.
right?
But then why are you in favor of and for this case report you're in favor of math as long as it's mild to moderate?
Yes. And
And you want to say that then your machine learning will be with the agenda that as if it was about severity,
yes,
then you would need machine learning because it can like differentiate the different layers as scaling and
yes,
redness.
yes,
So that's why like two distinct things with two distinct purposes.
yes.
Mm-hmm.
So it depends on what your agenda is.
Right.
And both papers are adding a lot of value.
Yeah.
Do you agree? Now, how will someone know? How will you even think that, oh, math could be useful between mild and moderate,
Hmm.
right? Unless you're a rheumatologist and you know the condition. See, there are data scientists out there, right, who know how these things work. Plus, there are rheumatologists out there, right? And they don't know how these things work. And will they ever consider that, oh, math can work?
Mm-hmm.
Our paper is aimed at convincing the rheumatologist that you can introduce math simple code in your clinic and you will be able to identify rash.
Right.
That is the goal of this paper.
So do you develop that math logic?
Yes.
Okay.
Again, everything is out there. It's just a
Hmm.
matter of how, again, see, I'm not sitting and telling that, oh, it's my idea, right?
Yes.
Someone had like certain idea in a certain way.
Mm-hmm.
And then I thought that, okay, if they are segmenting blackness, can I
Yeah.
segment redness?
Right.
How many pieces do I chop the redness into? Is
Yeah.
LAB the right format? Or should I make it RGB?
Hmm.
Why is it LAB color scheming the right format compared to RGB? Those are the things that this paper will address.
Right.
Right? In methods, you are stating the steps that you took for pre-processing, how you collected the information, how you did the pre-processing, how you are doing the, processing with respect to the math, like how many clusters are you breaking it down into, and then how you arrived at that logic, as well as what the output is looking like,
Right.
right? So those are the series of steps that you took to arrive over there,
Hmm.
right? Now, if you don't put in a lot of effort, and why should you spend your time interpreting from melanoma or interpreting from scleroderma or interpreting from somewhere else, right?
Because it's,
Dermatomyositis should have it also, right?
yeah,
That's it. See, dermatomyositis, people have not done much.
yeah, it's pretty rare to begin with, so probably it's harder to like develop things.
Yes. So what your
Yeah.
strategy should be if you want to become successful in myositis, go to scleroderma,
Hmm.
whatever they're doing, just copy it. They're 10 years ahead. You have 10 years career to catch up with scleroderma.
Yeah.
So that's the thing with, even this model, like where we are sitting.
Hmm.
Math will always have, if someone asks me, right, why are you not using machine learning? If let's say I'm having a poster in ACR and they'll be like, oh, with ChatGPT and AI, why are you not using that and why are you using math? Then I will tell them that, okay, have you considered how this works? We will
Right.
never achieve this level of accuracy. If I'm getting
Hmm.
90% accuracy using a big model, which you
Hmm.
can't run everywhere, can you
Right.
run ChatGPT on your laptop? You can't, right? My math model can run on a Nokia phone,
Hmm.
right? So what is more important to you? That becomes the question.
Right.
So every way you approach has its significance, and
Hmm.
it depends on, how you sell that significance
Right.
to someone. So these are the insights that, we need to portray through the paper. Then only it becomes easy to publish. Now,
Hmm.
the code that I did, right, is not performing as good as what Prakriti built.
Hmm.
Why I wanted to write this up is because she's not responding. If she would have responded, I am more than happy to include her code and be like, okay, this is what we did,
Right.
right? So, but another thing that a small limitation and small advantage that I would say we have is Nantakaran has put it as abnormal hand image versus normal hand image, right? In abnormal hand image, that is basically dermatomyositis rash. We can give the model without labeling, right? We can give the model and say that this is dermatomyositis, yes or no. It will come up with this, this unit architecture, and it will come up with yes or no. We don't know
Hmm.
what features it is extracting,
Yeah.
right? In one of the papers, what the model learned about melanoma, any image that had a scale in the image, it called it melanoma. Because when they took pictures of melanoma, right, they always had a measuring scale next to it. So it understood that if a ruler
Oh,
is there in the image, it is melanoma.
I see.
So when
Yeah.
we do pre-processing for the image, we have to remove all these,
Yeah.
features.
Right. That's why Nantakaran was also, I think, like marking the region of the rash, like specifically, so that everything else maybe gets removed and it
Yeah,
starts recognizing only that segment to be like dermatomyositis.
correct.
Maybe that's easier for the machine learning and it comes out
Yes.
more accurate.
Yes. So the conclusion that my friend gave was, he told that you should give me the mask. She has to label all the images.
Hmm.
Until she labels all the images,
Hmm.
there is not much we can develop in machine
Right.
learning. The only thing that we can do is math, little bit we can do,
Hmm.
right? If you want to prove your math model in those 30 patients, whichever your code works best for, you take that and you publish it. right? So that's the solution that we kind of came up with.
No, makes sense. I mean, yeah.
Yeah. So that's the case report, right? So
Right.
how many papers we have? One is the case report for the math. Second is,
Mm.
since we have the data set, the machine learning model. Third is the definite, what the data set is, the characteristics. That is a paper. And then fourth is, a bigger paper linking the model with the outcome measures.
Right.
That is the fourth paper. So just one project has these
Like
multiple
Dart has
papers.
these projects,
Yeah.
yeah, sub projects, yeah.
Yeah. So it depends on who leads. So I might be leading the more technical paper, Nantakaran might be leading the more clinical outcome oriented papers, and it
Right.
depends on that. So
Hmm.
any project will have, roles like this.
Right.
Did Hasini, do you have any questions?
No, I think like the thing you did on the paper kind of like you explained it really well. I have like a better understanding of what like how the machine learning works and how what each of the paragraphs specifically is supposed to talk about in relation to the study. So I don't have any questions.
Yeah. So that's what we expect in the introduction.
Yeah.
Right? And now what goes into methods? See, methods we don't know. Assume that the math works. We are starting off with that assumption, right? That the math works. So what should we do next? What would be like, did we ever go over the discussion section, Hasini?
Uh, I don't think so, no.
Can you, oh, you're sharing the screen. Can you open the paper, the outline that I have written?
Yeah.
So this is like the methods that I wrote. If you go
Yeah.
down,
Oh, oh wait, here it is.
discussion. So you tell me what would be the most important, like you heard the whole story, right? I want both of you to tell me, Hasini first, what is the first paragraph of the discussion you would like to read in a paper like this?
Um, discuss how your method is performed, address limitations. Um, I feel like wouldn't limitations like have to come, wouldn't limitations come first? Because then you're like, this is what the issue is, and then you would talk about like your method to address like your solution to the issue.
Mm-hmm. Okay. Vaidehi, what would you say the first para in discussion would be?
Yeah, I think it would be yeah, like how you addressed the current problem, what you did for it, and then you'd go on to discuss what are still the like limitations to your current approach as well. So maybe the research gaps come in like at the later end, but what you did and where you drew inspiration from also, I guess, like comes in at some point. Like, if you talk about the melanoma thing,
Mm-hmm.
if you do take inspiration from that, I think it comes like soon after, like after the first para maybe, where you say that you drew inspiration from this and it has proven to be successful in a specific thing, so it might have just
Okay.
helped you.
So your second para interpretation is spot on. That is what goes in the second para. Your first para is someone reads the result, right? Think
Mhm.
about it. Not everyone will understand your work in first reading,
Mm.
right? So what do they go for? They go to discussion and they see what are you even doing,
Mm.
right? Why you did it, what are you doing? So you kind of address like why you did it, right?
Mm.
But that is already there in the introduction. Our goal is to give people information that's not there in the introduction, right? So introduction, what you can't do, you can't quote your results,
Mm.
right? So in discussion, the first thing people come for to discussion for is to understand your result. So
Mm.
you have to guide them and tell them that what your result looks like, why it looks the way it looks. Does it make sense? So your hero outcome. If I do the math model, right? If I do math, let's take, I have 30 patients right now, like our DART data set, and I've done the math code. I see the difference. I can differentiate between mild and moderate very well, right? Through the code. But it is failing to differentiate between mild and severe or moderate and severe. So what is my hero answer at that time will be, this is great. This is a great tool to